an assistant professor in the Department of Mathematics, SNS College of Technology. This is a lecture video series on the most differential equations and transforms, and now we are on to the topic Fourier series. So first of all, we see what is Fourier series. We have already explained the contents on Fourier series, wherein it has to satisfy the Dirichlet conditions and f of x to be a periodic function. So what is the Fourier series expansion? As written here, f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n by x by l plus summation n is equal to 1 to infinity bn sin n by x by l, where the c to c plus 2l is the interval's length. And what are these a0, an and bn? These are called the Fourier's coefficients. So first of all, we need to find the Fourier's coefficient to write the expansion of the Fourier series. So what is a0? A0 have the formula like 1 by pi integral c to c plus 2l f of x dx. What is an? An is equal to 1 by l integral 0 c to c plus 2l f of x into cos n by x by l dx. In a similar way, what is bn? Bn is equal to 1 by l integral c to c plus 2l f of x into sin n by x by l dx. These are the required formula to find the Fourier series expansion. Now we will move on to the first problem here. What is it given here? Obtain the Fourier series of f of x is equal to x square. This is the function given in the interval 0, 2 pi. This is the interval given. And first of all, starting with the solution, we will frame what is the given interval here. C, c plus 2l is equal to 0.2 pi. This is what we are given with. Therefore, on comparing, c is equal to 0 and c plus 2l is equal to pi. If c is equal to 0, c plus 2l is equal to 2 pi means 0 plus 2l is equal to 2 pi and l is equal to pi. And later on, we will be starting with the step 1 process of Fourier series. Now what we have got l is equal to pi here. We are going to substitute l is equal to pi in the Fourier series and all the contents here, coefficients here. So step 1, what is step 1? Step 1 is to write the Fourier series expansion. What is f of x? Already we knew that f of x is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n by x by l plus summation n is equal to 1 to infinity bn sin n by x by l. So that is what we have rewritten here, and in place of l we have replaced with pi. So if we replace with pi, this pi and this pi will get cancelled and this pi and this pi will get cancelled. Therefore, on rewriting the function f of x, which is equal to a0 by 2 plus summation n is equal to 1 to infinity an cos n x plus summation n is equal to 1 to infinity bn sin n x. This will be the star equation of your Fourier series expansion. Next step number 2 is to find a0. What is a0? Already we knew that a0's formula is 1 by l integral c to c plus 2l f of x into dx in the interval c, c plus 2l. So that is what we are going to apply here. As per our problem, l is equal to pi and c is 0, c plus 2l is 2 pi. We are implementing all the values of f of x here, functions here. 1 by pi integral c is 0, c plus 2l is 2 pi, f of x is x square dx. What is this? Integration of x square dx is x cube divided by 3 within the limit 0 to 2 pi. If it is 0 to 2 pi, applying the upper limit, it will be 2 pi the whole cube divided by 3 minus 0. Therefore, what is 2 pi the cube? It is 8 pi the cube divided by 3 into pi. So what is the value of a0 here? a0 is equal to 8 pi square divided by 3. So this is what we have found as the first Fourier series coefficient. Now down here, we have taken the given problem as f of x is equal to x square. We got the interval as c to c plus 2l. It becomes like 0, 2 pi. And what is c? It is 0. C plus 2l is 2 pi. And we find that l is equal to pi. We are substituting all these values in the Fourier series in step 1. So you will get cancelled with these pi, and the remaining thing is cos nx and sin nx here. So this will be the Fourier series expansion of the given problem, and you are about to find a0, an and bn. Now what is a0? a0 is to find a0 is equal to 1 by l integral c to c plus 2l f of x dx. In a similar way, we are substituting the value of l here and the limit here 0 to 2 pi and simplifying it to find the value of a0 as a0 is equal to 8 pi square divided by 3. Now what we have to do in the next 2 steps? We have to find the value of an coefficient and bn coefficient. So what is the formula to find an? An is equal to 1 by l integral c to c plus 2l f of x into cos n by x by l dx. And what is bn? It is 1 by l into integral c to c plus 2l f of x into sin n by x by L dx. In this we will be substituting the value of L, C plus 2L, f of x. So on substituting it, you will have a formula like x square into cos nx dx. So the value will be like this. Therefore, for integrating this, we will be using Bernoulli's formula and finding the value of the integral. So this is how we are going to follow up the problem. We will continue this problem in the next video. Thank you.